And welcome back to another exciting edition of 8th grade math. I'm going to be your friendly host through another portion of 8th grade math. We're going to be talking today on chapter 8.5. If you'll look at page 335, we're going to be talking about applying inequalities. Alright, it looks like we're going back to another exciting edition here, if you will, of Mr. Hull's virtual classroom. Alright, so join me, my dear friends, on page 335, and we're going to be talking about applying inequalities, but we're going to be looking at examples and tying them into word problems. So example 1 says that Mr. Tobin wants to buy 4 new tires. As I always tell you guys, I like to write down whatever I read. I like to go ahead and write down. So let's go ahead and write down 4 if we could. So I'm going to write down 4 for the tires that he's purchased so far. So we got 4, and it says that he wants to spend less than 250. So that's going to say it's going to look something like less than 250. Okay? So I don't know the exact amount, so I need to set the 4 with a what, because it says what is the range of the prices he can spend. Well, he wants 4 somewhere in between that. So we're solving this just like we always do when we're solving for a variable. So we're going to divide by 4, which gives us 1n, is less than, and how many times does 250 divided by 4 equal? And we got the answer is 62.5. So that's going to be kind of the average that he's looking for. So this is going to be your unknown. So he can spend anywhere less than 250. And so this is going to be kind of like the happy medium, if you will. So again, let's just read what we just said. He wanted to buy 4 tires, so we know 4 for sure. That's how many he wanted to buy. And he wanted to spend less than $250. So that meant he could spend $249 all the way down to $0. And so the medium cost that he's wanting to put, this is per tire. That's the most he can spend per tire and still come out at $250. Alright, let's flip on over and take a little look at example 2. Example 2 says that we're looking for the sum of 3 consecutive integers. Alright, so this doesn't say even, it doesn't say odd, it just says consecutive. So consecutive means in a row. So that if we were doing 3, that'd be n plus 1, and n plus 2. Alright, because that says that we're looking for consecutive. Now, my next question is, it says that is more than 20. Alright, so the key word we hear is more. Alright, so they are going to be more than 20. Okay? So if we know consecutive integers are more than 20, we're going to write it something like this. n plus 1, n plus 2, and we say it's going to be more than 20. Okay? So first of all, we're going to add like terms. And so if we have our like terms, we have 3 n's. So that's 1, 2, 3. So that gives me 3n. Okay? Plus, I'm going to add my 2 constants, which is 3. Now what do I want to do? Well, I want to take the 3 and move it over to the other side. So when I do so, I get 3n is greater than what number? 17. So I want to get 1n, so how do I do that? I'm going to have to divide 3 into 3n and 17. So I want to do this a little higher so you guys can see it. So that gives me 1n is greater than, and if you do that, you're going to actually get, let's see, a decimal. I'm pretty sure if you divide, let's see what it's going to be. Yeah, it's going to be like 5.666. What did I tell you guys to memorize? Just quick fractions. So remember, 0.33 is 1/3, 0.66 is 2/3, and 0.99 is roughly 3/3. So this is actually going to be 5, because when you put it in the decimal, it's 5.66 all the way repeating. So it's going to be 5 and 2/3 because 5.66 repeating, and that looks like a terrible 5. Try to make it a little better here if you can tell, but that does say 5.66. So 5.66, that means it is 5 and 2/3 as our answer. So N and that's what the, even though you probably can't even see what I just did, let me see if I can bring it down just a little bit there. There we go, 5 and 2/3. You can see that a little better. Alright, so since it said consecutive, that just means in a row. We solve for our variable and our constant. Alright, so join me if you would on example 3. And I feel like we're moving along pretty good. This is somewhat of a short lesson, but bear in mind we are bringing forth word problems. So this time it says 4 times the smaller of 2 consecutive odd integers. Alright, keyword stands out this time as odd integers. So that's going to be our n plus 2. Okay? So it says 4 times. So that's 4 times something we don't know. So what would I put? Probably 4n, I would say, would probably be the best. So it says the smaller of the 2 consecutive odd integers is less than. So the number we just said, the 4n, it says less than 3 times that of the smaller 2. So when it says a smaller 2, alright, that means that we're going to be talking about what? N plus 2. Because that's what it takes to get your next consecutive. So, and bear in mind, anything I'm writing down is just words that I'm reading straight from your book, okay? So when I read it, I'm just trying to write down exactly what it says. So it's asking us now, because our consecutive odd, remember, would always be plus 2. It doesn't matter if it says consecutive odd or consecutive even. It's n, then n plus 2, then n plus 4 throughout infinity. Alright, now we just need to solve. So how do we do that? We need to, yep, you said it, we need to go ahead and distribute here, and that gives us 3n plus 2. I don't know why I just did 3, 2 plus 2. And then we got 4n. I bring my 3n over, that gives me 1n is greater than what number? Oh, you know what? I just did something. I just had a brain fart. Allow me to start over. I didn't. I meshed up on one thing here. Fail. Yikes. Let's go back from the distribution. 3n, and then when you multiply this, it's plus 6. Yeah, new guy here. All right, so I still move that over, and it gives me what? 1n, and it's going to still say. So yeah, same concept. I just accidentally wrote down the wrong distribution for 3 times 2. All right. So with that being said, and I'll circle it here so you can see what I'm talking about, because I want to make sure you see where we did 3 times 2. All right. So look at example 4. We're told that we have to solve negative 5x plus 7. Now, when you see this with a line through it, does anyone know what that means? That means not equivalent to. So you're saying that it's an inequality, but it's not equivalent. So you're saying it's not less than. It's kind of like if you, I don't know if you guys ever saw it, you don't see it much these days, but if you see a sign like that and has a cigarette in it, that means no smoking. And I'll draw my little fake cigarette here. Because you guys know that my artwork is pretty awesome. Oh man, you can't even see that. You gotta be able to see the cigarette, man. That's a masterpiece. But that means no smoking. This means not less than. Alright. But still, we're going to solve just like we have before. We're going to move the 7 over. And what does that give us? Well, we subtract it because it becomes negative. So that's 15. We got negative 5x All right. So my next question is, since it said it's not less than, that would mean that it would have to be greater than, right? Since it said it's not less than. So now we just solve, but here's another kicker, right? So this is where it might get a little confusing. Really stay on board and focus here. We're still going to divide by negative 5. But this gave us a 1x, okay? So remember we did reverse yesterday? Reverse inequality? Since we made a negative a positive, our sign has to be this way now. And our answer is negative 3. So remember, we did a reverse inequality here, okay? Because, yes, this right here did say that it wasn't less than. So we changed it right here, if you'll see. And I'll try to circle those in blue. So notice right here, I'm circling the not, and then I'm circling where we changed it. But since this was a negative 5, we did the reverse to make it positive. So that changed this sign back to, if you can see. So that was what we learned the other day, and that was called reverse inequality. All right. So let's go ahead and look at example 5 right here. And it says, so this has got A, B, and a C, and this will be our last example. And I'll let you guys get started on your work. But it says, write the corresponding inequality for the following statements. It says that we have 4 more. So again, we're going to write what we say. This one says 4 more than a number is at most. At most means it can go no further than that. That means, like, if it says a number is 100, at most 100, it won't be 101. It could be anything from 100 all the way down. So this one says 4 more than, at most, 84. So the number we're looking for is going to be n plus 4 is less than or equal to 84. That means it can be 84, but it can also be anything below it. B says twice a number decreased. All right, so twice a number would be 2 times n, because that's 2 times an unknown. All right, decreased. What does decrease mean? Well, it means subtract. And then it says by what number? Well, by 7 is at least 90. So it can go no higher than 90. So that means it's going to be at most 90. So here that means it can go no higher. All right, it can be anything up to that. So the top one we did was everything less than that. All right, so let's look at C. It says 40 less than a number. All right, 40 less than a number. So even though we said 40 first, it says less than a number. We don't know what our number is. So it's going to be n minus 40 and is not less than 95. So if it says not less than 95, that means it has to be what? Either 95 or greater. So the main thing I want you guys to really focus on here while you're doing these is just making sure that you're writing what you're reading. And just because you read something first doesn't necessarily mean that it's going to come first in the equation. Read the entire equation and then start building on it. You know, like we did on C there, it says 40 less than a number. 40 came first, but it was the second part of our equation. So we said n minus 40 is greater than 95. And our last one, it says 6 more than a number is not equal to 63. All right, so we have number, and then what does it say? More. More means to add. But it says it's not equal to what? 63. This sign that I'm getting ready to let you see down here means not equal to. This means not equal to. So with that being said, guys, I'm going to let you go ahead and get started on your homework, and I think that would be like, yep, there's the bell, Freds, and it looks like we've had a good time here today in Mr. Hull's virtual classroom. But feel free, if you have any questions, call me, and I'll be glad to answer them. And also, you have my phone number, so you can text me, call me, FaceTime me, whatever, and we'll make sure that you guys understand what we went over. And hope you guys know, thinking about you, and hopefully we won't have to do this much longer. But like I said, you guys have all my information, and I'll talk to you later.